name is Laasya Acharya and I'm a 6th grader at Mason Intermediate Elementary School in Mason, Ohio. When my sister was still fairly young, she got a severe case of pneumonia. I still remember being a toddler knowing something was wrong even though I didn't exactly know what. My parents rushed my sister to the hospital where she was quickly attached to a pump to help break up the phlegm in her lungs. She stayed at the hospital for many days. Luckily, my sister was fine in the end, but many are not. Pneumonia is a colossal problem for people around the globe. In 2018, there were 120 million episodes of pneumonia globally. Additionally, pneumonia is the leading cause of death in children, killing almost 16% of kids. Current detection methods such as blood tests and manual chest x-rays are slow and costly. Blood tests can be used to help confirm the illness and identify which kind of organism is causing your disease. However, identification isn't always precise. Manual chest x-rays can help to diagnose pneumonia and tell you where the germ's location is and how far it's spread. However, it cannot tell you what kind of germ is causing your illness. But what if there was a quick and affordable pneumonia detection solution? Introducing Nephthys. Nephthys is a neural network that can detect pneumonia through the use of x-rays. Neural network is a system of algorithms modeled loosely after the human brain, all to interpret sensory data. When I see a dog versus a cat, my neural network understands the difference between the two. In Nephthys, I was trying to recreate that for pulmonary images. I started off with working with the NIH to gather the data, which is pre-vetted by pulmonary doctors. Then I moved to image preparation. All images are resized to a 227 by 227 pixels with grayscale. The median filter was used to get rid of the background clutter. This allowed for a focus on my actual X-ray, not the background noise. Then I extracted certain features from my images, such as pleural effusions, abscesses, and infiltrates. These are the features I wanted my program to focus on, not the background changes. Moving on to the creation of my actual neural network. Nephthys utilized a 25-layer network with 9 different kinds of layers, such as convolution, where features are extracted. Next, I decided on my algorithm. I immediately eliminated some as polynomial regression, linear, and random forest. In the end, it came down to stochastic gradient descent or gradient descent. In the end, I chose SGD because it allowed for the ebbs and flows of a neural network, whereas gradient descent assumed that there would be a perfect algorithmic bowl shape. Next, I figured out my learning rate. If I had a learning rate of 0.001, my accuracy was 82%, 0.01 was 99%, 1 had 81%, and I picked 0.01 because it had a fairly short amount of processing time and the highest accuracy.
As seen in this confusion matrix, Nephthys was able to get 99% accuracy in testing in only 20.58 seconds.
Now it was time to put all the components together for the training of my final network. During this training, accuracy quickly skyrocketed while loss continually dropped. The final step was prediction. In this stage, the network was given images it had not seen before and asked to identify them. In the near future, I'd like to increase the amount of data used, broaden the ability of detecting more diseases, and move from a CPU to a GPU for increased efficiency. I truly believe that I can make this dream a reality. I want to see my machine being used in various labs and health agencies across the globe. I also hope to implement Nephthys in my hometown and across the globe. With the help of Nephthys, I truly believe that we can significantly cut down the pneumonia deaths yearly, simply one pulmonic image at a time. Thank you.